Hi guys, this lesson is called Factoring Quadratic Trinomials when a doesn't equal 1. So everything we did the last couple days was when a did equal 1. This is when it no longer equals 1. So if you wanted to use this strategy on the other problems, you certainly could, but if a equals 1, you can just fast factor for a much quicker answer. So if you think back to what we did in the last lesson, we talked about how a quadratic expression had a highest degree of 2. So did a quadratic equation and a quadratic function. Remember, a degree is the highest exponent in your expression, equation, or function. So we're also going to be talking about the fact that a is the very front coefficient in front of x squared, b is the coefficient in front of x, and c is the constant value that has no coefficient, no variable attached to it. So if you want to factor a quadratic trinomial when a doesn't equal 1, there's a few different strategies out there. We're going to start with the one that's the most visual, least traditional, but easiest to not make any errors in. So with this strategy, with all strategies for factoring quadratic trinomials, the first thing you want to do is you want to figure out what is a times c. So a times c here is 12, and b is 7. So we want to find factors of 12 with a sum of 7. So factors of 12 with the sum of 7 are 3 and 4. Now what we're really truly doing here is we're breaking apart that 7x in the middle. So since we're breaking apart a 7x, the two values we came up with are actually 3x and 4x. So in each and every one of these problems, this first x squared term always goes here. The last constant term always goes down here. And those two terms that you came up with, those break apart terms, they can go in either of these two locations. That is just your call. Once you've broken this apart, then you're going to say, what is your GCF of each row and each column? So the GCF of this first column here, try to come up with a highlighter that makes sense. How about we do gray? So the GCF of this row is x. The GCF of this row is 2. The GCF of this column is 2x. And the GCF of this last column is 3. So really what we're going to do is we're going to take this quadratic trinomial and we're going to say, oh, well that is equivalent to the two linear binomials, 2x plus 3 and x plus 2. So this is your solution. This box over here is just a strategy to get you to that solution. So in this example, take a second. What is a times c and what is b? So in this problem, we're going to find factors of 12 with a sum of negative 13. So our factors of 12 with a sum of negative 13 would be negative 12 and negative 1. And just like in that last problem, this goes here. This goes here. And then these two factors that we come up with go here and here. So we have our 4x squared and our 3. The two factors we came up with were 12x and negative 1x. and they can go in either of these locations. And then you're going to find the GCF of each row and column. And remember, you can tell if the GCF is positive or negative based on the closest value to it in the grid. So we can say that 4x squared minus 13x plus 3 is equivalent to 4x minus 1 and x minus 3. Okay, just like in the last problem, take a second to find your a times c and your b, and then figure out which two factors are the factors of the number you want and the sum of the sum you want. So our AC in this case is negative 30, our B is 13, and very oftentimes I'll get people that say 10 and 3, which would work if 30 was positive, but because 30 is negative, the factors we're looking for are 15x and negative 2x. So we're going to create our grid like we've been doing. And then we're going to fill in our spots. We're going to say this is a 6x squared, this is a negative 5, and then the 15x and the negative 2x is totally your preference, which spot they get. And then we're going to find the GCF of each row and each column. So 2x, 5, 3x, and negative 1. So we can say that 6x squared plus 13x minus 5 is equivalent to 3x minus 1 times 2x plus 5. Okay. Okay, so this last one looks a little trickier than it is. In this case, our A is 9 and our C is negative 4. So our AC is negative 36. And our B is actually 0. If you notice, there are 0 x terms. So factors of negative 36 that add to equal 0 are negative 6x and 6x. So again, just like we've been doing, we're going to put our 9x squared here, our negative 4 here, and then we're going to have a negative 6x and a 6x. And then we're going to find the GCF of each row and each column. So this would be 3x, this would be negative 2, this would be 3x, and this over here would be positive 2. So we get that 9x squared minus 4 is equivalent to 3x plus 2, 3x minus 2. Which, if you think back to yesterday, this is just like an extension of the difference of squares formula. I'm not a big fan of just memorizing a bunch of formula names, but difference of squares formula says a squared minus b squared is the same as a plus b, a minus b. So the square root of 9x squared is 3x, the square root of 4 is 2. So that's really what we've done by making this box. If you don't remember the formula, the box will always get you. So take a couple minutes and see if you can find answers to all 4 of these factoring problems. Okay, so for A, I'm looking for factors of 24. So factors of 24 with a sum of 10. I'm going to make my box 3x squared and 8, 6x and 4x. And then when I take the GCF of each row and column, I get x, 2, 3x, and 4. So A factors down into, let's get a color we can see. A would be equivalent to 3x plus 4 and x plus 2. Question B. My AC is 18 and my B is negative 7. So factors of 18 that add to equal negative 7. Well, if it was a negative 18, well, then we could look at it and say, oh, that would be negative 9 and positive 2. But because it's a positive 18, it's actually prime or not factorable or cannot be factored. Let's look at part C. We're looking for factors of 15 with a sum of negative 8. So in this case, that is negative 3 and negative 5. When I GCF each row and each column, I end up that my answer is 3x minus 5 and x minus 1. Last question. So my AC is negative 16 and my B is 0. So I'm going to set up my box. I'm going to say 16x squared and negative 1. And my factors are 4x and negative 4x. So I'm going to take the GCF of each row and each column. So I get that my answer should have been 4x minus 1 and 4x plus 1. Okay, so this last example is a challenge problem. And it is similar to the problem we did yesterday. So we're still looking for factors of AC that add to equal B, which in this case are 16 and 3. So we're going to set up our box, and we're going to put our 8x squared here, and our 6y squared here. And then we're going to put 16xy and 3xy. Remember, our variable was xy, so that's what both of these get. So then the GCF of that first column is 8x, and the second column is 3y. The GCF of this row, just x, and the GCF of this row is 2y. So we get that this factored becomes 8x plus 3y times x plus 2y. And if it doesn't look right to you, you could always double distribute it out to check your answer.